All right, so what are we doing when we're collecting like terms?
Simplify.
Simplifying. So that's one thing we should know. We're simplifying algebraic expressions. All right, and we're collecting like terms. That's one thing we can do. It's not the only thing we can do, but it's a start. We're going to do. Why does simplifying like terms, or collecting like terms, simplify things? Well, let me ask you this. How would you do this question? So if I ask you to evaluate that, okay, what would you do? Yeah. 7 times 6. And why can I do that? Because there are 6 lots of 7 added together. So which one is simpler? 6 times 7. So we think this one's simpler. Less to write out, we've simplified it. Right. What if I ask you to do 3 times 3 times? Okay. Could I simplify that in any way? We'll go with Nick this time. Would be 3. Oh, where's my pen? 3 to the power of 5, exactly. So it's a bit different. So this is where multiplication, we can say is repeated addition. And this is repeated multiplication. Do you remember what this is called? There it is, remember? What's it called? The little 5. It's not a variable, it's a number, it's a constant. It's an exponent, yeah. It's the exponent. Do you remember what the 3 is called? There it is. 3 is the base. That's not one we talk about too often. 3 is the base, 5 is the exponent. Becomes more apparent, good to know that when we have to deal with things like logarithms and things. Okay? So 3 is the base, that's the number that's getting multiplied by, and the exponent is how many times you multiply. Okay? So, what have I said to you to simplify? 5 plus 5 plus 6 plus 5 plus 4 plus 5 plus 6. What would be kind of like the simplest, quickest way to do that? What would you do? Say it again. I definitely don't want you to put exponents on y.
Because it's addition.
Because it's addition, exactly. Go on, Daniel, what are you going to say?
Okay, so we would do 5 times 4 plus 5 times 2.
No, you just get 5 times 4. It covers all of them.
Oh yeah, I meant 4, no.
6 times
6
2.
times 2, yeah, that's what I meant. And then
Plus
4, yeah.
4. Okay. Okay, you're quite happy with that, yeah? So when I need to do that, I would then say it's 20 plus 12 plus 4, and that's what I could do, yeah?
And that's 36.
And that would be evaluating, and the answer would be 36. But it's this stage that we're interested in, the simplification bit. Okay. Why didn't I mix up the 5s and the 6s to start with? So I've got 5 times 4. Why didn't I do 5 times 4 times 6 times 2? Well, for instance, let me ask. If I were to do, from this one, for instance, what if I were to do 5 times 6 times 4 times 2? Okay.
It wouldn't be proper, like, because it's addition. So like when you add up all the fives, you wouldn't find the 6.
Yeah. It's just not right, is it? If you think about what's actually happening, this does not describe that at all, does it? Could you... What would 5 times 6 times 4 times 2 look like as a set of additions? 5 6 times, then another 4 of those, then another 2. So how many 5s would I need?
12.
More than that?
18.
More than that?
Oh, 30.
6 lots of 5. So how many 5s have I got? 6.
6 5.
So that lot of 6 5 times 4,
Oh.
24 5s. 6 times 4 is 24. Times 2 is 48. So this would actually be 5 times 48. I'd have 5 plus 5 plus 5 plus 5. So what happens to the 6s and the 4s? They just go. So this doesn't make sense, does it? It obviously does not represent that first set of addition at all. Okay? So you can see it with the numbers, right? So, what about this one then? So, if I said 3 plus 9 plus 9 plus 3 plus 3. Yep.
3 times 3 plus 9 plus 2.
Okay. 9 times 3. Why would you say that? 3 plus 3 plus 3 is 9 as well. So we could actually also say 9 times 3. Does that work? 9 times 3? So it should actually be 9 times... 3 plus 3 plus 3 is 9. So I've got 9 times 3 now. But what he said is the 3 plus the 3 plus the 3 is 3 times 3. 3 times 3 is 9. And then I've got another 2 9s. Makes how many 9?
18. Is it 18?
2 9s. 3 times 3 is another
9.
9, which makes 3 9s. Right? We just check. What is 9 times 3? 27. What's 3 times 3? 9 plus 18 makes 27. So it's right.
Yeah, exactly. Got it.
Now, when we've got numbers like this, we can do things a little bit further. Sometimes numbers are nice and easy to deal with. However, what we want to move on to, actually before I move on to it, let's do one more thing with you. What about if I said 5 plus 5 minus 5 minus 5 plus 5 minus 5? Simplify it for me. 15 minus 15. Yeah. But let's do it in terms of what we were doing before. Can I say it's 1, 2, 3 lots of 5? But then what can I say? Okay, 3 lots of -5. What do I put in the middle?
Plus 3.
Well,
Oh, wait.
Plus. Or I could say it slightly differently, which I could say 3 times 5 subtract 3 times 5, no? Would that get me to the same thing? Alright, makes sense. Does that make sense so far? The answer is 0, of course, isn't it? Now, when we deal with algebra though, well, I shouldn't have said the word though, because algebra is just numbers that we don't know yet. So we just need to apply the same rules. So if I said to you, A plus B plus A plus B plus C,
whoa.
all that means is I haven't picked a number for A yet, and I haven't picked a number for B or C, but we can still simplify in the same way. So what do we write now? Why not?
Is it not typing?
Addition. That's
Do 3A.
8 times 3.
3A, thank you, yeah, is much better.
Yeah.
Plus 2B.
Plus 2B
Plus C.
plus C. Same way you would deal with the numbers. So if you ever kind of think, well, what should it be? You think, what would I do if each letter was a number, a different number? So what if we had 5 D's plus 4 F's plus 3 D's plus 2 E's plus F? Different. 8 D's
plus 5F
plus 5 F's
plus 2.
plus 2 E's. Yeah. Happy with that? And what we're doing is we're doing what we said at the beginning. We're collecting the like terms together. So as Michael said, we're collecting the things that have the same variable. So we're collecting the D's, we're collecting the E's, we're collecting the F's. Okay? I don't know why that's funny. Let's just check with, let's do W times W times W plus W plus W.
Right? So it would be dub.
Just have a moment, just double check your thinking. Go on then, Thomas, go on.
Alright. W to the power of 2 plus 2.
Yeah, good. So we have to separate the multiplication and addition. So what about if I said x squared plus 2x squared plus 5x cubed minus x squared plus g.
Can you put x squareds together?
Okay,
Yeah. Excuse me?
so how many do we have?
Here. 2.
So I've got 2x squareds, because 2x squared plus x squared is 3x squared, but then we subtract an x squared and get 2x squared.
And then nothing else is the same.
Nothing else is the same. 5x cubed plus g. They stay separate. So we don't smudge them all together.
Is there something you would happen like variable with no like numbers in front of it has to be?
No, actually. It's a good good points that you made. There is some formal way of writing these things out. Okay, so this one, I would leave it as it is. This one, I'm going to change it. So if I change it to what I should write it as, maybe you can tell me what should happen. So I'm going to change it to 5x cubed plus 2x squared plus g. So what rule did I use?
The largest number has to go.
Which largest number? Because actually this is not so clear, because it could be one of two things.
Ooh,
You are right with the largest number. Just which one do we pick?
it's the largest variable.
The largest variable. So when you say the largest variable, what do you mean?
Like the variable with like the bigger number.
But which number are you talking about? Are you talking? But the base is what? No.
The base is x.
The base is the x.
Oh, the,
Do you know what the
oh,
5 is called?
Is it the number of exponents? Oh, let's go.
Okay, so let's just check our vocabulary. All right, let's just check this vocabulary. So, what is the 5 called?
A base.
No.
That's five, like a big five?
This is called the coefficient.
Coefficient.
Okay. The x is the base. It is also, because it's an x, a variable. Okay? And this is the exponent. Okay, the rule for laying it out is we put the highest exponent first. Okay? This is called the order of the expression. Not to be confused with order of operations. The order of the expression is the highest power that we have to raise it to. So the highest power is cubed, so the order of it is cubed. Okay? Now, just to add something else to this one, this is called a trinomial. Any idea why?
There's
three terms.
Yeah.
So each separate term, remember we said collecting like terms? We've collected our like terms and we've simplified it down to 3 terms. Alright? So we've got a trinomial here because we've got 1, we've got 2, and we've got 3 terms. Each term is a variable term because what denotes a variable? A letter. Because it could change. The letter could change. Alright? Do you know what it is when we don't have a letter, we only have a number? Do you know what it's called?
Base.
No? Base is when we raise it to a power.
Instead of number and exponent?
Well, let's have a look at this. Let's collect this one together. So we've got 4y cubed plus 2x squared plus 5y cubed minus 3y cubed plus 7.
That's a number. That's definitely a number.
That's definitely. But if I asked you to simplify that, what would you tell me?
Put 4y squared and 3y squared together. And then, oh no, and the 5 on the
So what should come first? What's the order of this expression?
X.
Which is what?
The highest.
But which is it?
What? Oh, 5, 7. 7?
Not
Five.
6.
Why?
No.
Remember
The y cubed. Why is the y cubed? No, it is simply because that's the highest power.
I said
And the letter
starting.
okay.
So forget the coefficients, we think of the exponent, which is the highest exponent. So we should put the cubes first. Alright? So we've got 4y cubed plus 5y cubed minus 3y cubed is what?
A number y cubed. 4 plus 5 plus negative 3. I don't know.
Is it 11y?
Hang on. 4y cubed plus 5 is how many? Minus 3.
That's
6y cubed.
How would it be still
Minus.
Plus.
So the y doesn't count.
Ah, right, so you were doing really, really well, but now you're falling into this trap of trying to oversimplify things and just smudge things together. Remember what they are. 4y cubed is a thing, it's a term. I have 4 of them, y cubed. If I add 5 of them to it, I get 9 of them. If I subtract 3 of them, I get left with 6 of them. I've got 6y cubed. We don't stick the cubes together, all right? We've got 6y cubes, then we've got 2x squareds, and we've got plus 7. This is called a trinomial. Do you know what the plus 7 is called? It is called a constant.
Oh yeah, I know that.
You learned that. Why is it called a constant rather than a variable? It's just a 7, it never changes.
You know this is checker. Yeah.
Good? Glad it's starting to come back to you then. Right. Just one thing more then. So if I'm not going to give you anything to simplify this time, let's say we've got 5x squared minus 2x. Can that be simplified? No. Do you know what it's called? If this is a trinomial, this is a binomial. You ride a because it has
2 wheels.
2.
Code.
You've cracked the code. Okay. So we have a binomial because it's got 2. What are they called?
Do you have a tissue?
I don't. Why is it called a binomial? Because we've got 2.
numbers.
Two different numbers.
2 what are they called?
A letter and a number. It has letters.
2 terms.
Yes.
This is the first term, the x squared term.
And that's the second one.
This is the second term, the x term. What is the 5?
The
Base.
coefficient.
It's the coefficient.
That.
Okay, and we can say the 5 is the coefficient of x squared. What is the coefficient of x?
2.
Could be 2. Could be 2, or it could be. Look at it. It's not going to be 5. The coefficient of x is either 2 or it's
Minus.
negative 2. coefficient of x is what you, so the coefficient is how many x squared you have, or how many x's you have. So the coefficient of x is 2, but because we have a subtract 2x, we can say it's negative 2 is the coefficient of x. Okay? Yeah. Because the 5x squared, we have positive 5x squared, we just don't write that. So negative 2 is the coefficient of x. What is it with you guys doing the little hand signal? Because for me that could be highly offensive. Would you stand up in front of your parents and make that gesture? The two of you that I've seen doing it so far. No, not you. Anyway, so it's no longer on the video. So basically we're collecting like terms. You should be more than happy now to carry on working through exercise 4C all the way up to question 4. Okay? So I don't think we've got long left actually.
No.
A few minutes. Have a go straight at question 4. Get a couple done. Okay?